let us look at these questions. This is about the integrations. So the diagram shows the curve y equal to x over 2x squared minus 1 for x more than or equal to 1, together with a set of n minus 1 rectangles of unit width. By considering the sum of the areas of these rectangles, show that, okay, so we have to show the inequalities here. So what we can do now is let's build up the relationship between the area of rectangles and the area under the curve. So in specific, let's say I want to find out the area of the first rectangle. So I call this area 1. I need to use base time height. So I have to substitute 2. I have to substitute 2 into the function to find the height of the rectangle. So imagine that if I substitute 2 here, 2, and then I substitute 2 at the bottom, so I will get 7. 2 over 7 is the height. So the height is 2 over 7. Okay, so this point, let's say I label it first. This point is 2 and 2 over 7. And from here, we can find the area of the rectangle. As the base is 1, the height is 2 over 7. So the area is 1 times 2 over 7. That is 2 over 7. So area 2, let's take a look at this area. So the base is 1, the height. You want to find the height, you substitute 3 into the functions here. So you get 3 divided by 17. Okay, so as you know, this point, the coordinate is 3 and then 3 over 17. So the area 2 is hence, area 2 is base times height. So 1 times 3 over 17, so we get 3 over 17. So that is the area 2. Now, when you look at the last rectangle here, so what we can say is the last rectangle, the area, imagine this is area n minus 1. So this is area n minus 1. As you can see, area 1, they use value from here. Area 2, they use value from here. So this area should use value from here, which is n minus 1. So it is hence, imagine 1 as the base, height is substituting n to this function. So you will get the height as n over 2n squared minus 1. So that is the area n minus 1. Okay, so if I add up the areas, so I will get a series which is 2 over 7 plus 3 over 7 plus so on until n over 2n squared minus 1. So these are the total areas that shown in the diagram. And if I change it to summations, then it's going to be like summations of summations of r equal to 2 until n r over 2r squared minus 1. Okay? If I change it to summation, it will look like that. And at the meantime, I'm going to build up the inequality at the same time. So I know that what I have here are the area of rectangles, so I change it to summation. Now let's look at the area under the graph where you can get it through integrations. So I have to say that the area of rectangles, I write it down first, areas of rectangles is lesser than area under graph. So area under graph, we get it through integration. So the integration will be integrate from 1 until n, capital N. We integrate x over 2x squared minus 1 dx. So we continue in the next line. So I write back the same thing. Let's say at the meantime, let's see how to do the integration over here. Okay, we have to do integration here. How to integrate this? I write down the formula at the side here. So in blue color, the formula that we need to consider is integration of f prime x over fx dx equal to ln modulus fx. So let's say this is a and this is b. So when you do integrations, then we have to stick to this formula. Okay, now imagine that if the denominator is 2x squared minus 1, imagine that if you do differentiation of the denominator, so the differentiation is supposed to be 4x. So we don't have 4 here, so we can just put a constant 4 here. Okay, so of course if you put 4 there, you are changing the questions, you are changing the values of the question. So you divide by 1 over 4 out here. Okay, now what we have is I have the f prime of x on top, I have fx at the bottom, so I can use this formula to do integrations. Okay, so to do integrations, now let's continue with the integration. So 1 over 4 remain, then the integration will be ln and then modulus 2x squared minus 1 modulus again, and then put the limit and 1. Okay, now let's continue. On the left hand side, let's see what happened here is our our running index here start from 2 until n, but what you want to show here is a running index from 1 until n. So the first term is not there. Okay, the first term is not there. So imagine what is the first term. Let's imagine it about that over here. So you have to know that this is the general term. This is called the UR, r over 2r squared minus 1. This is the general term. So the first term, let's see. The first term is where we substitute 1 inside. So 1, 2, 1 squared minus 1. So 1 over 1. The first term is 1. Yeah, the first term is 1. The first term is missing, so I purposely create the first term on the left hand side of the inequality. So I put 1 here. That is the first term. Okay, so on the right, what am I going to do is I just continue the integrations. So 1 over 4, I have to substitute the upper limit. 2n squared minus 1 modulus minus ln modulus. Now I substitute 1 inside, I will get ln 1, but ln 1 is just 0. Okay, then and don't forget about one thing here. We add 1 on the left hand side of the inequality, so we have to add 1 on the right hand side of the inequality as well. So because of that, okay, let's adjust this. We have to add 1. We have to add 1 on the right hand side of the inequality as well. Okay, so let's say I put it in blue color. I add 1 on the left, then I add 1 on the right. Okay, so of course, why I add 1 on the left? Remember that I want the first term. This is the first term. Okay, I label this. This is the first term. This is U1. So I have U1 here, the first term. Then I have the second term here, third term, fourth term, and all the way until n terms. Is all under the summations symbol here. So if I combine these first term until n terms, where I can pull it in this way, it is the summation from the first term until the n terms r over 2r squared minus 1. Okay, so on the right hand side, let's see what we have now. We have ln modulus 2n squared minus 1, 2n squared minus 1. Okay, let's say I change it to bracket. Okay, I change the bracket plus 1. Sorry, 1 over 4 should stay in front. Okay, so I managed to get what am I going to show. Okay, so if you're wondering how come this is a modulus and how come I change it to bracket, after all, modulus is not necessary here because we know that when you do integration of this graph, you will get positive value. So if you get positive value, then this will be a positive value as well. So no need to modulus anymore. And now when you look at this is what we supposed to show. We managed to show it, and we put here shown. Okay, so this is how we get 7 marks. Okay, now let's move on. Next page. Part B. Use a similar methods to find in terms of n a lower bound for the summations. So in order to find the lower bound of the summation, now we need to consider the same graph again. So let's say I draw it up here just for your reference. Okay, here will be the y, here is the x, the graph will be like this. And now let's say this time I have to put my rectangles in a different way, which is like this, and like this. Okay, so in this case, I purposely create a rectangle so that my rectangles has area greater than area under the graph. So this is where I can get the lower bound. So let's build up the inequalities again. So area of rectangles is greater than area under graph. So area of rectangles, again we use the summations afterwards. Okay, so now let's find out the area one by one. So remember that this curve has equation x over 2x squared minus 1. So to find area 1, I need to substitute 1 into here, and I get 1 and 1, and that end up with just 1. Okay, so area 1 is 1. Okay, area 1 is 1. Area 2 is going to be similar to just now. I get 2 over 7. Okay, this is going to be 2 over 7. Okay, and then this last area, this is going to be area n minus 1. So area n minus 1 is where I have to substitute n minus 1 to the curve function, and I will get n minus 1 over 2 n minus 1 square minus 1. Okay, so this is area n minus 1. So the way that we build up the series of area is different for this scenario. So we have 1, 2 over 7, and so on until n minus 1 over 2 n minus 1 squared minus 1. So the integration is integration from 1 until n, x over 2x squared minus 1 dx. Now, for the series on the left, let's put it in this summation symbol. So we are going to take from r equal to 1 until n minus 1 for this case. And then r over 2r squared minus 1. On the right hand side, it is integration. So we can just refer back to the previous results and put the result here straight away. So from the previous results, what I can put here, I just bring forward the relevant informations from the previous results, and I have to put it as 1 over 4 ln. This is the result after integration actually. Okay, so this is the result, and after that we continue in this way. Our purpose is to find the lower bound, okay, lower bound, but we want to find the lower bound of this, but our summation is slightly different from this, where we have the first term, second terms, and all the way until the n minus 1 term. The n term is not in this series. You see, this is until n, right? This is until n minus 1 only. The n terms is not in this series. So what is the n term? We have to know this is UR, the general term. This is UR, 2r squared minus 1. So the n term that I mean is going to be n over 2n squared minus 1. Okay, so this term is missing. So I need to add this on both sides of the inequalities. So you can see it in this way. So I put the series, the summation again, followed by, I purposely add the n terms on the left. So when I do this, I have to add the same thing on the right. Okay, I add the n terms on the right. Okay, so remember, what is this? This is the n terms. Okay, now I'm going to combine this and this. This is the series from the first term until n minus 1 term, and this is the n terms. So if I combine this, it will become a series that cover up the first term until the n terms. And I just write back everything on the right. And from here you can see that our summation is greater than this. So this is the lower bound. Okay, so let's write it down. Lower bound is hence equal to 1 over 4 ln 2n squared minus 1 plus n over 2n squared minus 1. So this is the lower bound. Okay, so we finished the questions.